Hello, this is Guillem Godoy, and this video is one more among a series of videos where I try to explain how to program with Android Studio. In fact, this video will build upon a previous one where I showed how to draw several stars on the screen. And now our current goal will be to move them. Well, the idea is to move them downwards so that they could work well, for example, as the background of some sort of video game, like, for example, something like Space Invaders. I don't know, something where the background must give the impression that some sort of StarCraft is just moving ahead. And well, that's the idea. Our goal is simply to move the stars downwards so that we keep having a background that gives us or the user the impression that we're moving ahead. Okay. Well, okay, sorry. This is the code of that previous video. In order to remind what it did, we just play it. Okay. This takes a while, but that's it. Well, in this case, if I remember well, about 30 stars are drawn on the screen, and this button, the reset button, computes randomly a new positioning for each of them. Okay, well, as I said, our goal is to move them downwards as time goes by, and with that aim, we will need some sort of mechanism or of time control. I mean, we will need to iteratively execute something that moves the stars a little bit and draws them again, redraws them. Okay, well, this can be done, or this sort of iterative mechanism can be obtained in several ways with Java for Android, but one of them is the following. We need to declare a couple of variables. One of them, a handler, and the other one, runnable. Sorry. And they have to be initialized the following way. Okay, let me see. Yeah, there are several options for this. Okay, at this point, I can't explain why this should be done in this way, but somehow a handler is an object that can handle like different things, and among them a runnable. And a runnable has a run function that will be executed at a given time that we can that can be specified using the handler. okay, in the following way. This function post delete, where what we are doing here is asking the handler to run the run function of the runnable object that we just declared, and we must specify the number of milliseconds. Okay, let's call it I don't know, a constant number, waiting time or wait time. Okay. After wait time, the run function of runnable will be executed. Let's define this wait time. Okay. For example, 10 milliseconds. After 10 milliseconds, we will run this function that is yet to be defined. And well, what we want to do here is to move the stars. Okay, let's assume we will define a move function that will move the stars, and then we will want to redraw them again. Okay, once we have drawn them, in order to reflect that on the screen, we must let our, okay, remember we had here an image view object. We must let it know that its contents is no longer valid, so that it will reflect the changes. Okay, so our image view must call the invalidate function. This way it knows that it needs to refresh, okay, because what it is showing is no longer valid. Okay, and once, oh sorry, was I don't know why I'm in the on click listener. Okay, I wanted to do this, sorry, I wanted to do this in the run function. Okay, and once this is done, we need to set or to schedule a new execution of the own run function for the future. So we ask the handler again, sorry, to run again the same function after the same waiting time. Okay. Well, now it's yet to be defined, the move function. For example, here. Okay, what this function should do is to move all the stars. Okay, so analogously to previous ones, sorry, we can just call the corresponding move functions of each of the stars. Okay, but this is yet to be defined as well, and this is what we're going to do here. And what do we do? Okay, for now, let's just simply increase the y coordinate. Okay, in order to see that indeed the stars are moving downwards. Okay, so as you see, the move function simply asks each star to move, and the change that happens as a consequence is that the star moves 1 pixel downwards. Okay, and this is going to be happening every time. This is called, which so far this is defined to be waiting time, which is set to 10 milliseconds. Okay, well, let's see if that is working. Well, apparently this works. Maybe as a first change, okay, I'm gonna stop that. As a first change, we could make sure that once the specific star reaches the bottom, that happens when the y is bigger than 8, then it will be placed at the top again, okay? So in that case, for example, y could be defined, okay, if we defined it, I mean, the idea is to make it appear again from the top. An option, of course, would be to define it as 0, but then it would be it would appear suddenly at the top, the full star. If we want it to appear as if it was coming from above, then it's better to give a minus size value. Okay. And also we could take advantage to maybe place its x value at a different position. Maybe we could simply, for example, redefine the size so that a new size for a new star is computed. That way we'll have more variability as time goes by, right? So we just have to copy, for example, this instruction here, but in order not to repeat the code so much, I'm gonna create here a private function, set size, okay, which will do exactly this. Okay, similarly, we could have functions set x. Okay, for this instruction. Sorry. And similarly, set y for this instruction here. Okay, so at this point we need to set a new size and set, for example, a new x, okay? And the y places the star right above the screen, okay? Well, so let's see if this is working. Well, apparently that's the case. For example, now 3 stars are going away, and the 3 new stars show up, not necessarily with the same size. Well, that's difficult to tell, but I think that's being the case. Okay. Well. Okay. Now, observe that this waiting time has a strong influence on how fast the stars go down, okay, and has also something to do with the frame rate, though we cannot take for granted the frame rate is going to be exactly, I mean, this waiting time at all. I mean, wait time has something to do with how many times the run function is executed, um, or the period, or how long we have to wait for its execution, but that's not for sure. And it would be nice if the stars could be moved at a specific speed independently on from this value. Okay, we will try to do that. In, with that goal, we will need to pass to the move function how much time has passed since the last time we moved the stars. Okay, we will want to pass here a specific value delta, a double value. Okay, and our goal is that this delta is, as I said, the number, I don't know, maybe as a double the how many seconds or fraction of seconds have passed since the last time we moved the stars, and the distance traversed by the stars will depend on this time, the time that has passed, and a specific speed value which we can set as a constant. Okay, so for example, we could define as the speed value whose units can be pixels per second. Well, let's do not define it as a constant, okay? Because, for example, it could be interesting to define the speed as okay, a specific number of seconds, but for example, sorry, pixels per second, but for example, to make it depend on the size of the screen, so that, for example, if a speed is the height of the screen divided by 10, then we will make sure that each star spends 10 seconds for traversing the whole screen. Okay, so for example, we can define, I don't know, the speed as the height divided by 10. Okay, and yeah, how do you compute delta? Okay, we need to know the difference between previous time and current time. I'm gonna keep another value, which is the number of milliseconds I mean the current what's our current time, current number of milliseconds. Normally computers offer a function that returns the number of milliseconds that have passed since a specific date in the past, and we're gonna take advantage of that. For example, core time can be initialized. Okay, for example, we have a function which is provided in this way, which returns this value, the number of milliseconds that have passed since a specific date long ago. Okay, we can call to this function every time we call to the run function. Okay, and delta, sorry. Yeah, delta could be defined as the subtraction between both values. But we want delta to be a double value, and we want it to represent the time in seconds. So the number of milliseconds should be divided by 1000. Okay. Well, yeah, this delta, we find it as a double, and well, at this point, we have what we wanted. We are passing it to move, but the move function is not yet making use of this value, so we're gonna adapt this function here, and we're gonna simply pass it as parameter to each of the corresponding move function of each star, and now it has to make use of it. Okay, now the idea is that the y value should be increased. How much? Okay, we must move the y speed multiplied by time, right? This is the distance that we traverse after delta seconds, right? According to the speed. Okay. Now, what maybe it could be a little bit weird is that these two values are doubles, whereas the y is an integer. This could give rise to plenty of precision problems, and that's why I'm gonna change this from integer to double. I don't know if this can give rise to some issues here. Apparently, only at this point when we draw the star, we need to give integer positions. Okay. So let's do it. Yeah, I think that now it's okay. Good. Well, so now we are displacing or moving the y according to the speed. Okay, the rest of things seem okay to me. Let's make sure that this is working as expected. Well, perhaps it is not. Went crazy at some point. Okay, let me see. The speed is a double. Which is defined as height divided by 10. Well, if this is in seconds, this should be correct. Maybe the issue is with the delta here. I don't know. Okay, maybe I forgot. Okay, observe the curt time has not been updated after this subtraction. Okay, let's do it here. Well, that might be the cause behind this. Well, now it looks better, right? Okay, things are showing, moving. Okay, I don't know if it just spends 10 seconds, but more or less it seems to be the case. Well, now I'm gonna add an extra change which might make this look way better. Um, I'm gonna make small stars run slower in order to create or give an impression of perspective. Okay, smaller stars, I mean, allegedly can represent stars which are farther. Okay, and stars which are farther, if we move them slower, we can create like this impression, like, right, of, and this might look much nicer. Okay, so let's try it. Well, okay, remember that the size of a star is defined as the width divided by 10 or more, maybe more. Okay, so yeah, when before we had this extra term here, the sizes were defined as the constant width divided by 10, right? So but look, when the size is bigger, I mean, with a bigger size, we will have with bigger size, we want the star to run faster, right? So somehow the actual speed should be um, like directly proportional to the size. Okay, so that with bigger size we run faster. But okay, in the specific case where this size is exactly width divided by 10, we want it to be the unit, so that the closest stars will run at the speed we have defined at the beginning, right? So if we divide this by the value width divided by 10 here, we will achieve what we want. Yeah, maybe it will be good to make sure that this division is made for doubles. Okay. Okay, let's repeat this again. Now, with this expression, bigger sizes run faster, have higher speed, but for sizes of width divided by 10, this division gives 1 as result. Okay, that means that for smaller sizes, the stars will be running slower. Okay, so that's the idea. Well, let's try it and see if it works. That's it. Bigger stars run faster, small stars run or move slower. Okay, in order to make this more obvious, in the set size function, I'm gonna put here 30, let's say, so that the differences of sizes will be bigger. Okay, well, it looks quite nice. Well, at least to my view. Um, well, at this point, I'm gonna leave it here. But I wanna ask you a couple of changes. Um, the first of them is to paint the stars in different colors. Okay, maybe for each new star you somehow can generate randomly a new color. That is, you could have here, apart from these two local variables, also a new integer, which will be a color, the color of the star. You could have similarly to a set size, you could have a set color function which sets the color of the star randomly somehow. You can think about it. Okay, and both in set random values and when you reach the bottom, you could reset the color. You could call to the set color function. Okay, and once you do that, you will realize that there's a new issue. Observe that here we're getting the impression that some stars are closer than others because they run faster and they are bigger. But when you draw the colors, you will realize that some stars that are supposed to be farther are drawn above others which are supposed to be closer. That's because we are drawing the stars in order of index and not in order of size, right? So as a second change, it would be interesting before we draw the stars to apply a sorting, to sort them by size and then draw them from smaller to bigger size. That way we will avoid this issue and we will preserve this nice impression that this of perspective, right? Closer stars will be drawn later, so they will be drawn above stars which are farther. Okay, so that's the idea of the second change. Well, so I'm gonna leave it here. I hope you enjoyed the result we got and you can make the most of it. And I hope you have a lot of fun making the changes I just proposed to you. Okay? So see you in a future video. Goodbye.